Okay, so Alia came in back. All right, so recording start. Okay, so today we're going to do chapter 4. Everybody can see my screen, right? Yes. Okay, so today's topic is chapter 4, which include indices, and then you also have search, as well as one more is logarithm. Okay, so for this topic, main thing I have to revise about a few law of indices first. Okay, so law of indices, as I mentioned in the classroom. Okay, someone want to add me. Mm, how do I add me the person? Okay. Okay, Manisha is in. All right. So, for law of indices, you have a power m times a power n. So we will be getting a m plus n. Okay, so that's the first law. Okay, and then for the second law, you will have a m divided by a power n. So we're going to get a m over n. So that is the power, right? So first one, second one. So the third one, we will have a power negative n, for example. Then you will have 1 over a power n. Am I right? Okay. And then we continue with number 4. If I have a power m holding power n. Okay, so everything inside will have to power mn. We'll have to multiply with the power n. So for example, if you have like what do you call that? 7 uh 7e power n, then it will have to be 7 power n e power n. Is not everybody okay, right? So this is an example, okay, because I want you to clarify very clearly, okay, so that you won't confuse. So we move on to the next one, which is number 5. Okay, so you will have, let's say, a power um, m, but holding square root. Okay, so this square root, let's say, okay, like n root. Okay, so this is the same as if you have a power m, okay, and then the whole thing you have to times with 1 over n, okay, making it become a power m over n. Is it all right? Okay, so this is the same as if you have square root of n root lah, huh? The whole thing m. These two is the same. Yeah, these two is the same. Yeah, I think so far I can only think of this 5. 1, 2, 3, 4, 5. Okay, so these are the 5 roots that is useful lah. All right, so until this point, anybody has question to ask? So I'm revising a bit on the law of indices first. Okay, so moving to solve problems. Okay, so those who join, do you have anything you want to ask based on the questions? Yep. Anyone? No? Okay, so done. So in that case, all right, we will start to solve some questions. Mm, nice. Okay. All right. So that day we have solved until question number in class, right? We solved until number 4, I think. Number 3b, right? And then 3b, we were thinking about the numbers that can match, okay, which is here. Okay. Okay. Question 3. So have anyone tried to solve question 3 already? No, nobody. Okay, so as I mentioned, okay, so here we try to solve this question, All right, so when you first have, is it this one? This is already paper 2 lah. Yeah, let me. Page number 9.
Mommy,
Yeah, I think I can go back to here. Question 3B should be next page. Okay. All right. Okay. So this one. Okay. So let's move on here. So you will have 12 to power 3. Okay. So let us solve this question together. Okay. So let's start. 12. Okay. I'll use a blue color pen. Okay. So 12, 2 over 3. So what you can think of, like the other day we solved here, is that because without using calculator, okay, so it's a must for us to expand everything that we know. So 12, we can make it like 4 times 3 first, right? Okay, 4 times 3. And then holding power 2 over 3. Am I right? Then let's solve this together. Everybody take out a paper. And then 81 here. What you can think of 81 combination? 4, 3, 3, 9, 9, right? Okay. So 9, 9 is also 3 power what? We try to make the base the same, no? Okay, why? Because here you know that for this kind of question, right, the base need to be made the same. Then only you can like later on, because times and divide, you can plus the power. That's the way you solve it. All right. So 81 is 3 power 4, right? Right. 21. Yeah, correct. 3 power 4. Okay. 3 power 4 holding power 1 over 6. Then we multiply. Okay. 162. 162 is 9. Divide by 9 cannot. No. 3. Yeah. Divide by 3 can. So 3 times. 3 times. Okay. So it become 54, right? Divide by 354. Yeah, 54 can further divide with 9654, right? Okay, so another 3 power 2, 9, and 6 will be 3 times 2. Okay, do you get me? Negative 2 over 3. All right, so I write down first. Then we move on to 4 also can be 2. So now I sort of like have some idea that actually I have to make it to 2 and 3 will do. Then I'm going to combine them. Okay, so let's say make it here 2 power 2. Okay, 2 power 2 also have to multiply with 2 over 3. And then times 3 also have to multiply with 2 over 3. Is it okay? Okay, 2 over 3. And then divide by 3 power 4. 3 power 4 times 1 over 6 can become 3 power 2 over 3 also. Am I right? Yeah. Then times, okay. So each of these will have to multiply. So first, let me see how many 3 inside first. I have 3 power 1, 3 power 1. So I have 3 power 4 itself, right? So 3 power 4 itself, I multiply with negative 2 over 3. Okay, why? Because this power is outside of the bracket, so I have to multiply. And then I also multiply with 2 power negative 2 over 3. Everybody is okay with this step? Can I see thumbs up so far? Okay, everybody is following. Nurin, boleh ikut kan? Okay, good. All right. Yes, good. Okay, let's move on. So now we will group all the 2 together. So 2, this one you can multiply in, so become 4 over 3, right? Then you have the times here, another 2 here, right? So we're going to combine like this one, which is a base 2, and this one also is a base 2. So these 2 will combine together, which will become 2 power 4 over 3. Then we plus this one, minus 2 over 3. Is it okay? Because it's a multiply. Then we choose to multiply 3 now. So we have 2 over 3 is a divide here. So minus 2 over 3. Okay. Then what we can do? Continue with another plus, right? Plus 2 over 3. Then we can plus. This one is negative 8 over 3 here. Okay. Sorry, I wrote very big already. Okay, I'll write this base bigger lah, so as to clarify. Okay, so now we're going to simplify all this. You can use calculator. Okay, so you will have equals to 2. Okay, this one all is base 3. Okay, the denominator. So 4 minus 2, you left 2, and then 3 will be 2 and 2 over 3 done. So you're left with negative 8 over 3. So can we stop here? Can we stop here? Cannot, yeah, because we never leave our power as 2 over 3. Am I right? Negative. Okay, 8 over 3 there. So we will choose to put it like 2 and then power 2 over 3. And then we also divide by, let's say, 3 power 8 over 3. Okay, which follows back the rules that we discussed just now. Okay, one more thing to find out here is that, can you see that their power all have 2 over 3? Which means this is not the simplified form, you know. Which means we can think of like 2 over 3 here. Then this one, can we also change to something 2 over 3 outside? Can, right? Because 8 and 2, as long as I take out 4, then I can go back to 8 over power 2 over 3, right? So which means here, we can combine, okay, 3 power 4 is 81. So we make it like one fraction like that, holding power 2 over 3. That's it. Then only this is our most simplified version. Okay? All right. Is there any more question? No? Okay, let's move on. So we go on to the next question. Do you want me to solve one by one? Okay, we solve as many as possible, or you have specific question? Okay. Anyone? If still no, then we will just... yes. Yes, Jess.
Teacher, you got this answer, but then like the calculator is like a whole bunch of decimal numbers.
Yeah, that's why you see here or not, my dear. It says what the question has specifically mentioned that this one here, without using calculator. So if you put in decimals, right, sure gone one. They will know that you use calculator. Otherwise, how do you go and find out the decimals? So when they have without using calculator, there's no way that you can use calculator, but to play around with the power of fraction.
How evil.
Yeah, that's evil. You're right. Okay, but that's also another way. Make sure that you really understand it, isn't it? Okay, so let's move on.
Teacher, can we do 6?
You want 6, right? Okay, let's do 6 straight away. Wait, let me go back to the previous page. Okay, so we have here question number 6. Okay, so this one is log. Okay, so before I move on to log, right, I want to finish off with the power, the indices case first. Okay, what if number 5? Anyone can solve number 5 already? So this one just simultaneous equation, So this one you see everything in base 3, right? 81 also can change to base 3. 27 also can change to base 3, right? 3 power 3, 3 power 4. This one also everything can change to base 2. So this one give you an idea that you change to all the base the same, and then you just equal both sides. Then you can solve. Do you get what I mean? Okay, so that's the idea. Okay, I want to go to number 4 a while before I go into log. So number 4, let's see number 4 here. Okay, so question number, I skipped number 4, man.
Mommy.
1, 2, 3, yeah, number 4 is here. Number 4 is also, okay, 4a first lah, So 4a first, then I'll explain about the law of logarithm. Okay, so when we have 4a, so you see here, this one is a tree. Okay, this one is a tree. Okay, okay, so all right. Okay, never mind. Let me just write down whatever that I can have. Okay. I'm not very familiar with this template because the notability that I used last week, right? They require me to subscribe. So I try new one first before I subscribe that one. Okay, so this is one. Okay, so let's go back to the question first. The question says what? Okay, let us just write down over here. We solve. Okay, so we have 9 power x. Okay, blue still. So 9 power x plus 3 equals to 4 power 3 power x. So here give you an idea that 3 power x is something that you cannot get rid of, right? So you will change this to 3 power 2x first. I'll change to base 3. This one is 3 base 1. There's someone coming in. A minute, admit. Amina Wafia. Okay, should be 4 stem 2, 5 stem 2 also, right? Okay, so let's move on. Then you have 3 power 1 equals to 4, 3 power x. So it gives you an idea that, you see, this is 3 power x. This one is 3 power 2x. So if I let 3 power x become y, for example, okay? So isn't that in that case, I will have a 3x and then square. And then this one, I move it here, minus 4 3 power x plus 3 equals to 0. So does that give you an idea? Meaning you can see that this is like a y square, isn't it? Y square plus, minus 4y, okay, minus 4y plus 3 equals to 0. Do you see that? So that's the hint. Once you got stuck, right, you think of the possibility that you can relate to quadratic. Okay, so this one becomes equal, right, equals to 0. So now what can you do? We can do what? Factorize, isn't it? Take out calculator. Can you tell me what's your y? Anybody? Can you tell me what's your y?
3,
Yes, y is 3 some more.
1.
1. Okay, so it's 3 and 1. So we put in here y minus 1, y minus 3 equals to 0. So I want to emphasize here again that make sure you have this equal to 0. Okay, so let's move on. So can you stop here? Can you stop here? Before you move on, you check. They want you to solve this equation, which means you are yet to tell us the x. Am I right? So you are not here for y. Y is you let yourself one. Okay? So this is what you let yourself. So you cannot just stop here. So you have to put 3 power x equals to 1. And then 3 power x equals to 3. Okay, so here you can see that 3 power x equals to 1. Anything can make 3 power x become 1. Anybody? Only when x is what? Remember I told you before, any number power what will become always equals to 1. Remember or not? Yes. Yes, very good. Humaira and Shazana, you are right. So 3 power 0 equals to 1. Hence, your x equals to 0. Okay, so another one is very clearly you can see 3 power x equals to 3 power 1, right? So x straight away you can make it become 1. So that's it. Okay, is it very difficult here? No, it's very easy, right? But at first you may not be able to do it. That's why you must try a lot of different type of questions. Okay, yeah. So now I want to go on to number 4b here, where we start with the law of logarithm. Okay, so for law of logarithm, okay, the idea here is that, so I'll put here the short notes here. Okay, so for the law of logarithm, the idea here is that why do you need law of logarithm? Okay, so the logarithm itself, the idea here is that because when you sometimes have, for example, 3 power x give you 0.25, for example. Okay, so 3 power what give you 0.25? There's no way that you can know because we usually memorize 3 power 1, which is 3, 3 power 2, 3 power 3, 27, you know, right? So all these are round number that can be relate with. But now when you come with 3 power x, right, there's no way that you can solve. So that is why they come up with the system of logarithm, which is to make us understand clearer. Okay, so how to deal with log? Okay, so log is something like that. Okay, so you have 3 power x. So 3 has a friend of power x here. Okay, so let's look at this case here. Okay, 3 has a friend power x here. Okay, and then you have 0.25. Am I right? So the idea here is that the 3 here is a base. The x is a power. Am I right? So when you have this 0.25 is what you want to solve, but it is alone here, isn't it? So when you want to change to log, right? So it will be the uh, log that comes to find the lonely one first lah. Okay, so meaning the lonely one will be 0.25. So the log will be coming to find 0.25 first. So it will stay with 0.25. So now I'm teaching you how to change index number into logarithm. So when you want to change to log, right, log will come and find the lonely number first, which is 0.25. And then here you read it as a base, right? 3. So this 3 will also become the base 3 here. Then you left with x here alone. Now it left alone x, which is what you want to find. So can you tell me if you have log 0.25 base 3, how are you going to solve it? So if you have the newer calculator, you can change the base to base 3. Am I right? Okay, but when you have the older one like the one that I do, then it's very hard to find. So the idea here is, I repeat, whenever you have, okay, we come with easier number first. 10 power x, you get let's say 300. Okay, so again the same thing, we want to find 10 power anything that give you 300. Okay, so we say that we cannot solve this number, so we would like to change it to log. Okay, convert it to log. So again, when you want to change to log, the log will come and find which one. We will come to find the lonely number first, which is 300. That's why here you will change to log, log, and then you will have a log 300. Remember, because when you have the lonely number 300 alone, log would like to come to find 300 so that it has companion. Then the base here, which you say as base 10, right? The 10 will become here the base for log also. All right. Then the x here become x that you want to find. So can you press the calculator and tell me the calculator, the older one, like the one that I'm having, the black color one, is only base 10. Okay. So can you give me the answer for log 300 base 10? Can you give me the answer? Log 300 base 10. No response. Okay, 2.477. Thank you. Thank you, Kashen. 2.477. So now I would like you to do a quick check. Take out calculator, key in 10 power 2.477. 2.477. Do you get 300? Do you get 300?
No, I get 299.91.
Yeah, because we round off, right? 0.91, you can round up to become 300 lah. Because we round up this 2.477 just now. Okay, so which is why you cannot get the round number, but it is the closest possible one. Okay, so do you understand now that when your x is 2.477, you can solve these tough indices when you use log. Okay, so that's the idea of logarithm. So far so good. So far so good. Can I see thumbs up if you're okay? All right, I can see everybody is good. Yes, all right. Yeah. Santini, okay? Awulia, Shazana, Manjari, Tanusha. Okay, yes, good. All right, let's move on to the next part. So now, when you understand how to convert one to another, I want to move on to the law of logarithm. Okay, so this one is how you convert. So now, if you move to law of logarithm, okay, let me place this over here. Okay, so I will come to here, which I will use this space for law of logarithm. Remember law of logarithm? Law of logarithm. Okay, so first thing is like what I just mentioned just now. Okay, first one is if you have 10 power x equals to 300 just now, so you're going to put x equals to log 300 and then base is 10. So base is forever a base. Either is 10 power x where the 10 is a base here, the x is an index, or when you change it to log also, the base is still a base 10 here. Is everybody okay? All right. Then we move on to the next log. So when we have law of logarithm, okay, where you need to, okay, I think this one is better, thicker. You can see clearer, right? Okay, so when you have the next one, law of logarithm, we said that if I have log A plus log B, regardless, we should be the same base, base 10, base 10. Then you will have log A times B. Is it okay? All right, and number 3, when you have log A, okay, log 10A minus log 10B, what do you get? Log minus log, you get log A over B. Okay, and then the fourth one, you have the next one, which is change base, right? Change the base. If let's say you have log a, let's say log C base D, and you want to change everything to log A. So you write down first log A over log A. Okay, that's my method lah, I have log C base D. I want to change to base A. So I write down by log A first, the base that I want. Then I will put C on top, D at the bottom. Okay, so that is how I do it this way. Is that okay? This one I write. Okay. Okay. So just now I said 10 power x equals to 300. So we're changing to x equals to log base 10, 300. Is it clearer? Yep, everybody can follow us. So can we start to solve problem? Can I see thumbs up so far? Oh, Val is in. Okay, good. Everybody can follow. Okay, so let's start to solve the question with log. Okay, so we have just now here this question, right? They ask you to express log base 10 square root AB over C in terms of log A, log B, and log C, right? Okay, so let me see here. Mm. Okay. Okay, so I'll do it here. So we will use black color to solve this question. Okay, so I'll do it here. Question 4B. So this is 4A. This is 4B now. Okay, so we have log base 10 square root AB over C. Okay, square root AB over C. So how do we do it? Okay, so what comes to your mind when you first see this? You will have to expand first, right? Remember the law that we have just done over here? When you have something divide, you have to open it back, right? Open it back, how do you do it? See it here? This one. Okay, we will use the law for number 3. Law for number 3, where they already give you A over B now on the right, you're going to make it to the left so that you can solve them. Okay, so we're going to open up, okay, to this part. Okay, so you have 10A, this one. Okay, so let us open it up, become log base 10, your square root AB, right? Then minus log base 10, okay, log C base 10. Okay, then, okay, one more that I forgot to mention about the log is that if you have a power, then you can bring it to the front. For example, here, I'm going to log base 10 A plus B. Okay, why? Because this AB, oh, no, I cannot open like that. Sorry. Technical error. Should be log AB. I open up holding power half first. Then I need to minus log base 10 C. Is it okay? So this one AB power half, right? Another law of logarithm is that if you have the power in front, let's say you have, okay, let me use red color. Okay, so I have log, let's say I have log C power 2. Then my 2 can come to the front for log base 10 C. Is that okay? So the power can bring to the front to multiply. Same thing, your 2 also can go back. Okay, but remember this one is AB power half, right? So you will need to put in, okay, the half to the front. Okay, and the half here is actually applicable to both A and B. So you need to put a bracket here, which is for log 10. Okay, and then you have A, and then also plus log, and then you have B, okay, and then you minus your, okay, let me erase this off. Then you have here B and then minus log C. So the question only want us to express this one in terms of log 10A, log 10B, and log 10C, right? Okay, so which means we can just open it up. This half applies to here, apply to the first term, also apply to second term. So if I were to open up this big bracket, it would be half log base 10a plus half log base 10b minus log base 10c. Isn't it I have fulfilled what the question want, where I express this expression into this. So full stop. Okay, any question to ask? Can I see thumbs up if you have any? If you are okay. Okay, everybody is good. Remember to ask question if you find that there are parts that you don't understand. Okay, Santini is okay. Awulia okay. Shazana, Kena, Noreen and Manjari, Tanusha. Okay, good. All right. So let's move on to the next part. So any more question? Just now, Jess was asking about number 6, right? So let's go on to number 6. Okay. So number 6 is over here. Over here. So they want you to change to base 4, right? So when they give you base 8 and base 2, it's very clear that you have to use the law where you change the base. Remember, I'll write it here again. Okay. The idea here is that, okay, the law, I use red color. Okay, the idea here is that you will have log, let's say, C base D, right? Okay, so I want to change to base A. I will just write log A divide by log A. So bear in mind, this log A divided by log A, then I put here C, I put here D, right? This thing is different from you have log A C over D. They are different. Okay, why they are different? Because this thing on the right, this one, it can open to log AC minus log AD. Do you get me? And this one on the left is you are changing the base. So it's the whole log, divide the whole log. Do you get me? Okay, so they are different. I need to clarify with you. Okay, please take note here. I'm going to put a star here. Okay, I need you to really understand this part. All right, so let's go to solve question. So we have number 6 here. Okay, so number 6a first. Okay, so they tell us that log x base 4 is equals to k. So they want us to express each of the following become in k. Okay, in terms of k. So now we have log x base 8, right? So we say already, we want to change to base 4 in order to express in k. So you will change to base 4 first over log base 4. Do you get me? Change to the same base first. Okay? Then you will have x on top and then 8 at the bottom. Is that okay? Everybody is good, huh? So I'm just using what I have written on top. All right, then the next one is, okay, here the top one already reached the k, right? So you can happily put in the k first. Okay, but the one at the bottom have some technical problem here. Why? Because okay, whenever we do question like that, right, we try to uh obsolete the whole log. So the only way that we can obsolete it, right, is to make it into an index number, which is base 4. Okay, so you'll have log 4. This one is 4 here. Okay, so how do you come up with 8 leh? Let's think. If I have uh, square root. Okay, if I take 4 power 3 first, 4 power 3, what do you get? 64, right? 64, then I can square root it, then I can get 8, no? Am I right to come back to here? So which means you have to come up with an idea that you have to take the whole thing power 4 power 3 and then you square root it. Okay, so in short, you are doing it this way where it is k over log 4 base 4 and then it's power 2 over 3. Okay, it's power 2 over 3. Make sense? Try again, calculator. 4 power 2 over 3, you get 4 power 3 and then, no lah, wrong. 3 over 2, right? Because it's 4 power 3 ma, then square root ma. So 4 power 3 over 2, correct? Yeah, correct. Okay, so you check here, then you know. All right, so in that case, we can obsolete. Okay, now how do we obsolete? The next law of logarithm is that if you have log 4 base 4, you will get 1. Why is it so? Why log 4 base 4 you get 1? Because remember,
it's the same thing.
yeah, remember when you have the base is 4, right? And then okay, let's say now you are changing it back. I just want to prove to you, okay, let us write it down here. Okay, now at the bottom here, let me do some yeah, I should. Okay, all right, so here I'm going to write in red, okay, so that you can take more note. Okay, so I'm going to go back to red. Log 4 base 4 equals to 1. This is another law. Why? Now you see, just now when we say that log come to find the lonely one, right? Then the base will come here to join because it's kepo, come to join as a base in 4. So now if log leave, okay, so now I write here, log 4 base 4 equals to 1. What if I'm changing it back to index number? Okay, so the log is going to leave. So this kepo base will go back to find the base here. So the 1 here become index back, right? So the 4 be left alone. Isn't that 4 power 1 is equals to 4? Am I right? Isn't that 4 power 1 is equals to 4? That's how we obsolete the log 4 base 4 because it's equals to 1. Do you get me? So now I'm going to obsolete it. Okay. So come back here. Then I'm going to have my k still continue. Okay, then over, I have my log 4 base 4 done. So my 3 power 2, it's a number here, right? Because I can bring it to the front. Okay, let me do one more step in case you cannot follow. Okay, meaning this one is over, and then it is 3 over 2. Log 4 base 4 is 1. Okay, so I will have k divided by 3 over 2, which equals to k times 2 over 3. That's why my final answer will be 2k over 3. Is that okay? Is it very tough? Not really, right? Okay, then we move on to part B. So I will erase this one because this one is just to prove to you that log 4 base 4 is really equals to 1. Actually, you realize that log 5 base 5, log 10 base 10, log 200 base 200, they are all equals to 1. Because remember when log leave, right, the base go up there. So 200 power 1 is always 200. So that's how the reason is. Okay, so we go on to part B. Part B, let me continue here. Okay, so this one is log, you have 8x power 3 base 2, right? Okay, so we have to change everything to the base 4. Okay, I recommend you to change the base to the same thing first. Okay, so we'll change to log base 4 over log base 4. So you're going to have 8x power 3 and then 2 here. All right, so you do like this first, easier. Okay, then only you start to expand. Okay, so expand meaning we will do like just now. the law of logarithm, when it is multiplied, we open up to become plus. Okay, so you have log x plus log base 4 x power 3. Am I right? And then over log 4 2 here. Can you see it? Can? Okay, then we will continue from here. Equals, okay, so log 4 base log 8 4, right? Just now we already shift it to become 4 power 3 over 2, remember? So we just write that 4 power 3 over 2, right? And then plus, okay, this one, the 3 here can bring down, right? 3 here can bring to the front, log 4 log x base 4, and over, okay, this one, the 2 here also the same. You have to be creative lah. You have to make it become 2. So it can be log 4. How to make 4 become 2? Square root it, right? So we just power half ourselves. So I want to highlight here is that it has to be a little bit creative here. Okay, like here you have the 8. The 8 here become 4 power this and this. Do you see that this is what creative is? Okay, change to the same base at the same number with your base in a logarithm because you want to obsolete it. So same thing here. When you have 2, you change to 4 power half. Okay, so let's move on. All right, so I'm going to solve it. Okay. So continue. All right. So we will have here, okay, log 4. Okay, so this one we bring it to the front first. 3 over 2 times 1 now, because log 4 base 4 is 1. Then we will plus with 3. Okay, this log x base 4 is our k, right? See here, log x base 4 is k. Yes, we substitute k inside. Okay, then over. This one also the half can bring in, and then left 1 here. Okay, so simplify. You have, okay, this one is simple maths, Okay, coming to the end already. Let me write it here first. So equals to 3 over 2 plus 3k. Okay, this whole thing divide by half. Okay, divide by half. Can you see? Right, there no space already. Never mind. I erase and rewrite it back smaller. All right, so I'm gonna have here 3 over 2, okay, plus 3k over divide by half. Okay, divide by half.
You can see the autoplay on the background. Oh, see so many cards over there.
Okay, divide by half here. So it's going to be, okay, 3 over 2 plus 3k. You need to simplify that, huh? So 3 over 2 plus 3k. What do you have? So it will be, because you divide by half means you times 2 lah, right? So it will be 3 over 2 plus 3k. This whole thing here, divide by half means times 2. So you will get here 3. This one times 2 to both, okay? So 3 times half, 3 times 2, you will get 3, and then you will get here 3x, 3k. Okay, 3k. So it's 3k here. So 3k times 2 becomes 6k. Okay. All right. I do realize that actually there is a shorter way. Okay. because here, yeah, there's actually a shorter way. I just realized it. You see, what happened is that, okay, I will do here with a purple color pen. Okay, alternative. Okay, alternative. Why do I say that it is alternative? Because you see, if I have this one, right, I just realized that my 2 and my 8, they are, it can be easier to solve because why? 8 is actually 2 base 2. So I don't have to change for this one. Meaning I can actually open up first, right? I can actually open up first. So I come to this point where I have a 2 and then, sorry, log 2 first, yeah? And I have log 2, 2 power 3, okay? Then I log 2 base 2 power 3, okay? Plus, this one here, then only I change because the 3 I can move to the front first, okay? Then this one, I straight away can solve and get 3 already. Do you agree? This one I can straight away solve and get 3 in front. Then here become 1. Then this one, right, I just have to change this part where log 2x, right, over, I want to change to base 4, sorry. I'll have to write base 4 first, okay? So I'll change to log 4, log base 4. Then only I change the x over 2 here. Do you get me? Then it can become simpler because at the first place, I have 3 already. Then here I have another 3, then bracket k over half only. Why k over half? Because the same thing here, 4 power half will become half by itself. Okay, same thing here, same thing like here. So I just substitute in. So k divided by half become 3 times 2k here. This one become 2k here. Okay, this one become 2k. Okay, so I'm going to get 3 plus 6k. So this one can be faster. Because why? Because you don't have to deal with so many layers of fraction. Okay, so this is an alternative. So yeah, in this case, the base 2, because of 8 is 2 power 3, it makes this first part simpler rather than you have to deal with this. Both ways are also okay. Depends on which one you like. Okay, so can I see thumbs up? Do a quick check. Is everybody okay? Good. Okay, Manjari can, good. Santini, okay. Yes. All right. Aulia, okay, and Shazana. Okay, good. So let's move on. Okay. So we will move on to the next one. So which one questions that you want to ask? Any more? What if we go on to solve like tougher question? Because next week, if can, I would like to, what do you call it? Okay, we solve some cert first, huh? Let me see. Cert is in question 10 and also question 10 is very easy, huh? So you will solve something like, okay, this one I have. Okay, we will solve paper 2, question 6 first. Okay, paper 2, question 6. Paper 2, question 6. This one have question 5, last page. Yeah, this one. Okay. All right. So question 6 is here. All right. So let's start. Okay, I'll start with blue again. All right. So question 6. Simplify each of the following. So this one is simple question. Why? Because this is cert. Okay. So cert question, remember, you just have to rationalize it by multiplying it with its conjugate. Okay. The term is called conjugate, which is its partner, right? Okay. So conjugate means you just have to solve it very carefully. Then you should be able to do it. All right. So let's start with 6A. 6A, we have part 1 here. Everybody can see the question, right? Let's solve it together, okay? So you have 1 plus square root 3 over 2 square root 3 minus 1. Okay, so to multiply with its conjugate, remember we have to look at the denominator. So top and bottom multiply the same thing. So 2 square root 3 we write down. Okay, so this one is a minus 1 here, right? So the conjugate will be plus 1. Okay, so top bottom you have to multiply 2 square root 3 plus 1. Is that okay? And okay, so now we continue. So the bottom. Remember the idea of conjugate is actually A minus B times A plus B so that you will get back your A square minus B square. Last time you used to start writing from the right first, a square minus b square equals to a minus b, a plus b. So the idea here now is that you are given the left-hand side, a minus b. So you yourself have to multiply the top and bottom with a plus b so that your denominator can become a square minus b square. That's the idea. So now this one, if you're not sure yet, right, you can actually do it slowly, whereby 2 square root 3 minus 1, 2 square root 3 plus 1. Okay, you can do it slowly. Okay, 1 plus the top is square root 3 multiply with 2 square root 3 plus 1. Okay, so the bottom now is that 2 square root 3, okay, whole thing square, isn't it? Because why? This one multiply this one. Then this one multiply again with plus 2 square root 3. And then this one will be multiply. And we go top. Okay, this one minus will be minus 2 square root 3. And then this one will be minus 1. Because minus 1 times plus 1, you get minus 1. So in other words, here, the plus 2 square root 3 and minus 2 square root 3 actually cancel off. So are you convinced now that you actually get back the a square, which is here, and the b square, which is here, and it's a minus? All right, so now the top you have to do the same. Okay, also you will have 1 times 2 over square root 3. Okay, so do it one by one. This one cannot cancel off already. So 2 square root 3 plus 1. Okay, and then 3 times plus square root 3 times 2 square root 3, then plus 1 times square root 3, square root 3. Okay, so the bottom here, we can simplify. Okay, 2 itself squared, you get 4. Square root 3 squared, you get 3. Are you with me? 2 square, you get 4. Square root 3 squared, you get 3. Right? And then minus 1. This is the bottom. Okay, and then the top. Okay, now we simplify. 2 square root 3. And then you have another plus. Can you see here? 2 square root 3 plus 1 square root 3. So you will get 3 square root 3. Why? Because the square root 3 is like a. So you have 2a plus 1a, so you get 3a, right? Then we plus 1, continue. Okay, this one, square root 3 times 2. So we write it here slowly, times 2 square root 3. So this one, write nothing here means 1 lah, right? So 1 times 2, you get 2 lor. Square root 3 times square root 3 ne? Square root 3 times square root 3 is square root 3 squared. So you left with 3. Do you get me? So you get actually 6. Is that all right? So we are not done yet because we haven't come with a simplified version of that. Okay, so we move on. So now we are getting 3 square root 3 cannot do anything already. But here you can plus 7 over 4, 3, 12 minus 1, 11. So that's the final answer, 11. Okay, so the answer is 3 square root 3 plus 7 over 11. Okay, any more question? Okay, so that's the part A1, 6A1. Anyone face problem? Can you do together with me or not? You don't just watch me doing, Please do together with me so that you can, what do you call it? Revise at the same time. Okay? Can I see thumbs up for this question? Yeah, everybody okay? Okay, let's move on to solve 6B. Can you repeat? Oh, okay, Noreen, which part that you need me to repeat? The whole thing? Okay, so I'll repeat one more time, yeah, everybody. So let us see here. Second line. Okay, second line. Okay, second line is the idea of second line is like that. If you have A plus B, okay, like this one I have here, right? Okay, so the idea here is like I use orange color, A times A. So you get A square. No? So that's why here I'm doing 1 times 2 over 2 square root 3. This one. My first line here is 1 times, yeah, 1 times 2 square root 3, I get 2 square root 3. Okay, and then 1 times 1, okay, 1 times 1, I get 1. Is that okay? Then continue with the next one. So this is like expanding. So the first one is 1. 1 will have to times 2 over 2 square root 3, and then 1 also have to times 1. So then I solve this 2. Then now it comes to this term pula, square root 3. Square root 3 have to times the first term. So I write here square root 3 times 2 square root 3 is a multiply. And then I solve it here for you, right, just now. Square root 3, okay, square root 3 times 2 square root 3. The idea here is that you will get 2, and then square root 3 times square root 3, you get 3. Is that okay? All right. Then I move on to explain for this part. Will be square root 3 times 1. So I get here square root 3. Okay, so you get it already? Noreen? You get it already? Amna, you have problem, is it? You raise your hand? Okay, good. All right, so this part you have to do it slowly. Okay? Yeah. So for this type of question, right, please make sure that you have this line. Make sure that you have this line. Make sure that you have this line. Okay, this line that I highlight, right, is a must to have. Okay, because they want to see you doing it by showing the square of it. Okay, if you from here, you are someone fast, right? From here straight to here, right, you get wrong. Yeah, it's like that. You get no marks. I'm sorry to say that. It's actually not so right lah, but they don't give you marks because you don't show the yellow color step. All right. So don't what do you call it? Don't risk your marks. Okay. So the yellow color line is important. Okay. So let's move on to 6A2. Can I move on? Can. So let's go on to 6A2 here. Okay. So 6A2, it's not difficult. Okay. 6A2, you just have to do like just now. Okay. So I'll use back my blue color. Okay. So 6A2, say that, okay, if you have 1 over 3 square root 3 plus square root 7, okay, then you have a plus square root 3 minus square root 7. Okay, so if you have this, then remember, for fraction, if you want to plus them, the denominator must be the same. So that's why we have to do it like very long one. So they are so happen to be conjugate to one another, right? So just multiply their conjugate lah. Meaning, okay, just revise in case you forgot. Okay, when you want to do fraction like this, right? If you have 3 over 2, you want to plus with 1 over 7. So what you will do is both of them must become 14, which is the lowest common multiple. Am I right? Then the 2 have 2 times 7, and then meaning top and bottom times 7, top and bottom times 2. Do you remember this? Okay. Yeah. So that's why you will come to 2 times 7 plus 1 times 2, 1 times 2, 2 here. Is that okay? Can, huh? So that is a quick revision of your basic. Okay. So let me erase this off so that I have space to solve. All right. This is the basic maths. You always must be remembering it lah. Okay, let's start solving this one. Okay, so my blue color. All right, so I will have square root 3 plus square root 7. So let me write down here that I'll have square root 3 plus square root 7. Top and bottom both also multiply with square root 3 minus square root 7. Yeah, so you imagine that this one already got plus ma. So the top you want to multiply with the conjugate, which is square root 3 minus square root 7. Right? Because the top and the bottom will times the conjugate. And then here also times the conjugate. Okay, so here plus, I continue with plus. So 1 here, continue 1. I multiply with the conjugate, which is square root 3 plus square root 7 here. Do you understand? Because they are the conjugate, square root 3 plus square root 7. So here also times square root 3 plus square root 7. Is it okay? Then here is top and bottom, square root 3 minus square root 7. Okay, here is also square root 3 minus square root 7. Is it okay? Can ya? Okay, let's move on. So now you're having square root 3. Okay, so this one here, remember we have to show square root 3 whole thing square and then minus square root 3 square root 7. Because why? I do it slowly. Purple color, okay. Square root 3 times square root 3, I got square root 3 square. Square root 3 times negative square root 7, I get negative square root 3 square root 7. Am I right? Then now, this second term. Second term is square root 3. Okay, so square root 7 times square root 3, I have plus square root 3 square root 7. Square root 7 times square root 7, I have minus square root 7 whole thing square. Am I right? Okay, so can understand, right, Nurin? Keep doing more, okay? Then you will understand even better. So we continue. Okay, the top one is 1 times square root 3 square root 3. 1 times square root 7 minus square root 7. Then I plus square root 1 times square root 3 square root 3. 1 times square root 7 plus square root 7. Okay, so now we will simplify them. Okay, how to simplify? The bottom square root 3 plus square itself, so you will have 3, right? And then this one, you see, this one is like minus AB. Then you plus another AB. So minus 1AB plus 1AB minus and plus, so you can cancel them. Am I right? So this one become minus 7. Yeah, 3 minus 7. Then the top also the same. You have plus square root 7 minus square root 7, right? Minus square root 7 and plus square root 7. So you will get, okay, now square root 3 plus square root 3. What do you get? It's just like a plus a. You will get 2a. So don't confuse, yeah? This is square root 3 plus square root 3. So it's a plus a. You won't get a square punya kan? So you will get 2a because it's a plus a. Just now one is square root 3 times square root 3. So it will get 3. Because it is a square root 3 holding square, you get square. Do you get me? Don't confuse here. Can I write something for you to take note here? Square root 3 plus square root 3, you are getting 2 square root 3. Okay? You are getting 2 square root 3 equal. Square root 3 times square root 3, you are getting square root 3 holding square, which you are getting 3. Okay? Understand this part? All right. Then we can solve our question now, which we will get here equal 2a over negative 4. So the negative cannot put at the bottom. So put it into 2a blah. You see. 2a. Okay. This one should be 2 square root 3. So 2 square root 3, 2 square root 3. The negative put in the middle, then you are done. That's it. Okay. Is it very difficult? Oh, no, not yet. One more step. I just realized it. The 2 and the 4 can further simplify. Okay, so it become 2. So your final answer is negative square root 3 over 2. Then only perfect. If you stop here, also no step, no marks for the final answer. Need to further simplify. So 2 and 4, remember, they are multiple of each other. So you get square root 3 over 2. Okay, any more question? We can continue to solve 6b, shall we? Yeah. 6b is also a good question, right? This one, if I put in exam, sure gone one. So let's do this, okay? Now, 3 equals to 5x and 5 equals to 3y. So they ask you to find the value of xy without using calculator. So Jasrine, here again, without using calculator. So we don't want to see any decimal place. Always remember that. Okay, so we will solve it here. Let me see. No. Okay, so let me add a new page lah, Okay, just now, again, we have 3 power. One more. Okay, we have 3 power. Let me check that. 3 equals to 5x. 3 equals to 5 power x. Okay, and 5 equals to 3 power y. Okay, so they want you to find what is xy. That's the question. Okay, so how do we do it? So first thing, there's no relationship at all between them, isn't it? Why? Because 3 and 5, they are not multiple of each other. They are not power of each other, right? So what we can do, we have to borrow Mr. Log. So remember, when Mr. Log come, Mr. Log will find number 3 or 5 power x. Mr. Log will find number 3 because number 3 is alone. So Mr. Log want to find those that need companion, right? So the story go this way. We start from log. Okay, usually we log base 10 easier. So log base 10 can be written as LG only. Okay, can be written as LG will do. So log, we will 3. Okay, log 3. Log come and find 3 equals to 5x, right? So remember the base will come here to become the base. So log base 5, 3 equals to x. Is this okay? All right, so now I have, oh yeah, cannot. If I change to like that, right, later I will have problem because log 5, very difficult later. No. Okay, I won't do that. Okay, so what I will do is I log both sides. Another choice that I have is I log both sides. What do I mean by log both sides? Which means I log 3, I also log 5 power x. There's a difference. Why? because if I change this into a log, I need to solve for x. That is the reason. Okay, but here, because without using calculator, so there's no way that we can find log base 5, like what I did just now. So I don't do that. Okay, because log base 5, I cannot solve without calculator. So now, the only method that we can solve without calculator is we change to base 10 and we log both sides. So when we log both sides, right, log also find 3, log also find 5x. It is a different thing. You are log both sides. So when you log both sides, right, you have log 3 and then you have log base 10. Okay, I write down here. Okay, log 3 base 10 and log 5 power x. Okay, 5 power x, I can move the x to front, right? Can I move the x to the front? Can, right? So I will move the x to the front and I have 5 here. Okay, so now it seems like I have to, okay, I don't know what I should continue. Then I do the second one first. Okay, sometimes you can have like that. Never mind. So we log base 5. Here, this one also, we log both sides. Okay, so we will log here, log base 10, log 5 base 10, log base 10, 3 power y. So I'm going to do same thing. Okay, I'm going to put my y in front first. Okay, so what should I continue? So it seems like I can see that I have x, I have y. So what if I try this way? I express y alone. So this one will be y and 10 and then log base 3. Am I right? And then how about this one? If I put my x alone, I'll get log 10 3 over log 10 5. Am I right? So a lot of you will have problem here. You will get stuck now, right? So how to continue? I also don't know. Then we look back at the question. What does the question want? The question asks us to find xy. Oh, so they actually want xy, which means they want us to put x times with our y. Am I right? So which means, okay lah, we find xy for them. So xy, we have our x which is log base 10 3 over log base 10 5. Then we have to multiply with our y, which is log base 10 5 and log base 10 3. Okay, so here now, this one is a simple multiplication. When you have, let's say example, when you have 2 over 3 times 3 over 2, what will you do? 3 and 3 can cancel, right? 2 and 2 can simplify. So log 5 and log 5 can simplify. Log 3 and log 3 can simplify. All become 1. So the answer will become 1 times 1, which will be answer 1. That's it. Okay. So can I see hands? Are you okay? Good, everybody? Tashwini, okay? So I'm just telling you that sometimes when we do question, we may get stuck. But no worries. You look back at what the question wants. Make sure that you are doing to the direction to solve the question. Okay, So Jasreen, you are good? Yeah? So let us solve one.
Yeah, I'm eating, yo.
Sorry? You
Yeah,
are
but
okay,
I'm
right?
eating, so.
You are eating, no worries. Okay. So, any more question to ask? So today we only managed to solve a few but I also have already snapped photos of the long questions like this. The long question like question 2. Okay, actually this type of long question, right, is not scary at all. Okay, it is just that they will give you this function and then you just put in the value that they give you and then calculate what do they want. Okay, so this chapter basically doesn't run away from what that we solved today. Okay, they are just changing the pattern. So I want you to try solving all the questions here. Okay, for those who don't have this paper, right, later I'm going to share this PowerPoint together with the recording, okay, so that you can uh, solve all, okay, because these notes itself should be good, okay, for you to solve the questions. Okay, just as a summary before we stop today's lesson, I would like to just do a quick summary. Yeah, last week I actually forgot to do summary. So now we will do summary. So chapter 4, you have three things here: indices, cert, and log. So now, are you able to apply better now? These 5 law of indices here. A power m times a power n, you get the power multiply, the power plus. Then when you have the a power m divide a power n, you get the power divide. Then a power negative n, you have to change to 1 over a power n. So a power m, the whole thing power n, you actually get a power m times n. Okay, then the square root itself will become the power is 1 over n. So if you have power m, then you have to power m lah. So you simplify it, become a power m over n. Is that okay?
Teacher,
Yeah.
number 2 a power m divided by a power n should be minus.
Oh, correct. Yeah. Thank you so much, this one. No wonder I find it like something wrong. Because I was stuck here. I was looking at number 5 and number 2 like the same, oh. So what's the problem? Thank you so much. Very good. Who is this? Kai Shen. Okay, let me write it in m minus n. Thank you. Okay, so let's continue. Yeah. Next time you correct me on the spot lah. Okay, otherwise people will hear until like "Nye, nye, nye." Thank you. I didn't realize that. All right. So another next part that we have gone through is the law of logarithm, right? So for law of logarithm, okay, we have done it in here. Okay. So law of logarithm, there should be about 5 lah. Okay. 6 to be exact. Okay. So they are all here. Okay. So wait, okay. So they are 3 power 10. Okay. So this one is to change a index number into logarithm. Okay. So you will have to put the base to the together with the log 300. Okay. So become x equals to log 300 base 10. Okay, so you just have to remember my story. So if you want to change any number to log, the log will have to find the lonely number, and then the base 10 here will come and join them and be kepo. So it will still be the base. Okay, base 10. Then the x will become alone now, which is what you want to find. Okay, and then when you have log a plus b become log ab. Log a minus log b, you get log a over b. Okay, and then if you want to change the base, I'll change to the base the same. Okay, I would like to add on a bit, which is the 5, where just now we say you have log b power n, right? Then the n can bring to the front, become n log b. Okay, and we also have the 6th one, which is log a base a always equals to 1. Log b base b always equals to 1. Log c base c always equals to 1. Okay, so there are 6 law of logarithm. All right, so and then the cert, when you do the cert, right, usually we just rationalize them by multiplying the top and the bottom, the conjugate. Okay, the conjugate, which is the complement of it, because you want them to have the a square minus b square, which give you a minus b and a plus b. Okay, so that is all for today. So can I see thumbs up if you find that today's lesson is helpful? It's helping you to understand better, yeah? So try to do more. So we will discuss in class next week. All right, so next week, I think we will be shifting to linear law. Okay, we will be doing linear law. Okay, first, okay, because I find that linear law is a chapter that you definitely can score lah. Okay, so we have 2 more weeks. So next week linear law, then 22nd we will do progression. Then 29 I will stop, because 29 you will have to prepare for your exam by yourself, because I believe this week you have UAS, you have your oral BM, and then your other papers. So I will stop on 29. So next 2 weeks we continue. Even though this week is Deepavali, but Deepavali not yet start, right? So yeah, we will
Hey
do it on
teacher, I thought our oral test already over.
not oral test, sorry, the BM and the BI paper and your UAS, right? Or preferably you want to stop 22nd so that you can prepare your UAS. Okay, so we will either
What is UAS?
UAS is your, wait, I stop my recording first. Okay. UAS is your